Hey guys, it's IDW, and today we are going to be doing another video on our Redstone computer. So yeah, if you guys remember from last time, we were building this instruction decoder, which is going to basically make it so that we can input instructions into this thing. And today we are going to be finishing off this entire thing, hopefully. Last time I decided that the video was taking a bit too long, or becoming a bit too long, but no matter what happens today, I am going to be finishing this whole thing off once and for all, and hopefully we're going to be able to input a few instructions and minus synchronization, which we're probably going to be doing next time. This thing should be working perfectly. So yeah. Anyways, so the first step that we're going to be going through today is we're going to be basically, of all of the single operanded instructions which we finished towards the end of the last episode, we are going to be basically, first of all, stringing the unique ones that need to go into these guys, and as you can see, I've found a better solution for this wiring that's a bit faster. We might end up needing to change the delay on this because of synchronization later, but for the moment this will work just fine. So that's the first thing, and so we're basically just going to be taking these two instructions right here, which are going to be the only two instructions that need their inputs into the ALU connected up to this side, and we're basically just going to be connecting them up. So the first question that we need to ask ourselves is, which ones of these are we going to actually be needing? And the only instructions that are based off of these two and these two alone are going to be carrying in, which is going to be an incrementing instruction. So let's just make this right here carry in, and then we can just string it underneath there. And then this one right here is going to be the other one, which, if you remember, is going to be, invert B, which is actually going to equate to, decrement. And as for carrying in, that is going to equate to the increment command. And there we go. So now it's just going to be a question of stringing these two up. And yeah, so I'll see you guys when I'm done with that. As pointless as this thing may seem, seeing as we rarely use it, having something like this where you can just easily arrange your thoughts when you're building something as complicated as a computer like this is really useful. And so what I've done with this basically is I've basically just listed out all of the commands that we're going to be having for single operanded instruction format, and also the digits that are going to assign them. And so yeah. So with that figured out, we can now actually go ahead and just make it so that for the 000 we're going to increment, and 001 we're going to decrement. Now 000 is easy enough, but the problem really comes up when we have to do 001. And that's because we really haven't figured out which one of these is going to be the least significant bit and which one's going to be the most significant bit yet. So let me figure this out really quickly. So first of all, with this one, so for the single operand, no, that won't help. So this is the only one that's going to be unique. So that means that this command is subtract. So that means that this is 0 and this is 1. So that means that in this decoder at least, and I should put a block there, in this decoder, this right here is the least significant bit. Sorry if that was a bit confusing to, wait a minute, oh my gosh, I'm starting to get confused myself. Oh, I see what we're doing, never mind. Yeah, so this right here is actually this right here is the least significant bit of this one. So that means that over here this should be actually, sorry if this is going nowhere, but I think what I should do is I'm going to swap these around so that this is the least significant bit, because the least significant bit normally is at that end, so yeah. Once again, sorry this is a bit confusing. The last time I did something like this I actually cut it out because it was just not doing anything, and I don't need a slab there, come to think of it. But yeah, basically what we're doing is we're making sure that we make it easier for our programmer to understand what's the least significant bit and what's the most significant bit. So with that all figured out, we can now say that this thing right here is going to be the least significant bit. So when we are, decrementing, this is going to be on, but for this guy right here, and we're going to need to invert these, but whatever, this is going to be on. And otherwise, it's all going to be the same for the rest of them, so I'm going to build that off camera, and yeah, I'll see you guys when I'm done with that. Oh my gosh, this trick is starting out to be super useful. I'm really going to have to remember this trick that I'm using here, where you basically can run these two into the same block. It's being really convenient, but anyways, as you can see, I've wired these up, and I actually took an extra step and figured out basically how we're supposed to, the signal strength, and I've actually inverted them too, so now they can just come straight up here, and we don't have to worry about signal strength or anything, and yeah. So with that all worked out, that's just about everything for that side. Now we can actually really move on to this side of the computer. So yeah, so with the remaining commands, the real question is which of having these where they are, what's going to be the most optimal place to have like one particular command that's going to like go to one of these particular wires. And these wires over here are where all of the functions are going to go to eventually, so yeah. Anyways, so, but the solution that I'm going to be using in order to make it so that it actually can go pretty much as fast as possible is that I'm going to make it so that the commands that need to have the input that goes into the ALU come in here, I'm going to make it so that they're the ones that are at this end, and the ones that get to be closer to here are going like around in this area rather than that area are going to be these three. So that's just a signal strength thing. It doesn't really matter what we're doing probably, but just in case, it will be nice to have a bit more elbow room when we're syncing stuff up. So yeah. So without any further ado, let's figure out which one of these is probably going to be the furthest out. And just by looking at these, that looks like it's probably going to be the bit shift operation command. So that's going to be, we're going to need to turn this on if either of the shift commands are active. So I think that both of these guys right here are going to be the shift commands. So the shift commands are 1010 and 1011. So that's what these two wires right here are going to be assigned in the decoder. So I'm going to build that off camera, and I'll see you guys when I'm done with that. Alright, there we go. So now this one right here is going to be the 011 command, which I believe is, shift right? Okay. So yeah, so now we just need to hook these guys up to basically these two wires. So we have two commands right here. First of all, we have the bit shift operation, and that's basically going to be a multiplexer that's just going to make it so that we're actually sending the value in, rather than just sending the value straight out. We're going to actually be shifting it. And then the direction that it gets shifted is determined by this wire. And the thing that I'm forgetting right now, which I really should know, is which one of these is if shift left is towards the least significant bit or not, or if shift right is towards the least significant bit, and I'm just forgetting that right now, and it's something I really should know, but for some reason I don't. But anyways, I think what I'm going to do is I'm just going to OR these two together like that, and then I'm going to say that the one that I can switch these guys up right here later. And basically I'm going to say that the one that's going to be in the one state for this is going to be the one that's closest to it, so I'm just going to be bringing this around and up into here, and then I can just take this wire and you can just plug it into this. So yeah. Anyways, later I'm going to look up which one exactly is that so I can see if back here I need to change this or not, but whatever. So yeah, I'll just build that, and I'll see you guys when I'm done with that. Alrighty, I've got a bit of bad news. It turns out that, first of all, the orientation that we've got back here is wrong, so that's easy enough to fix, but while I'm fixing that, I'm also going to tell you a bit more bad news. It turns out that right shifting is shifting downwards, so towards the least significant bit, and that basically makes it so that it's the opposite of which direction it is in our computer if we face that way. So if we're facing that way, then shifting to the left is going to be going up, but really it goes down, and so yeah, and that's unfortunate because it makes it so that it's going to be a bit confusing when people are actually starting to program this stuff. So yeah, it's really too bad that it had to end up like that, but yeah. Anyways, now that we're done with that, we can move on to trying to figure out the problem of which one is this going to be of all of our functions. So if we look at all of our functions, we've actually already done all this side, so we can get rid of it. And actually, now that I look at this, I think we're actually done with this, because all the branching stuff we're not going to be working on right now. Wow. And I don't even need this wire right here. Wow. 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 That really turned out to be really simple. I thought I was going to need to be able to invert B from this side, but yeah, it seems like that's everything that we can do right now, because everything that's on this sign is just branching and stop, which is a clock function, and branching is a memory function, which we don't even have yet, nor have we even discussed what it is, so we can safely say that we're done with that. So I guess that all that we really need to do at this point is to just hook this guy right here up. And that's really all we're going to be able to do, as far as the actual physical functions go. We also need to hook up the modes, though, and I probably should have brought those around to the other side. Well, I guess that I'm going to take one of these and bring it around to the other side so that it's going to the right side, and then I'm going to be seeing you guys, and we're going to be hooking up the modes. And after that, it's just the registers, and then everything, in theory, should be completely complete. Okay, I accidentally forgot to record the rebuilding of this so that it can come out here, but all I really did was I just moved this wire down so that I could make space for it. But yeah, so now we just need to take this and we need to hook it up to the actual mode that is going to be coming out of memory. So yeah. And this is actually probably a good time to extend all these wires out, because these are the wires that are actually going to be coming out of memory, and they're going to be going straight into the CPU, if they're an instruction, that is. That is, if they're formatted as an instruction. We're going to be talking about the difference between instruction memory and data memory later, because there's some very important things. Actually, we're going to be talking about that relatively soon, and talking about von Neumann machines and Turing machines. That'll be something to look forward to. Those are always really fun. But anyways, all we're going to need to do now is we're just going to need to take this wire right here, and we're going to need to hook it up to the mode. And we're also going to need to take these wires here, and we're going to need to hook them up to the registers. And I should probably build the other two. You know what? I think I'm just going to build the rest of these off camera, and then I'm also going to hook up them. I'm going to extend them out a bit further. So yeah, I'll see you guys when I'm done with that. Another really important thing to do, especially if you're using World Edit, is to back up your worlds, because this actually crashed when I was setting this entire area to Redstone, and I don't know why that happened, but whatever. Everything seems to be just fine, unless I find a chunk error around here somewhere, which I haven't yet, but yeah, so basically, yeah, just keep in mind, always, if you're building a computer, you probably want to back up, so yeah. Anyways, so with these things built, what we can now do is we can basically hook them up into these things, which we built on one of the last videos. So yeah, without any further ado, let's get straight into that. We're going to be needing to build these on both sides, and I think I'm going to need to reverse these guys again. Oh yeah, I finally got that on camera. If you didn't see what I just did, I broke the block and I replaced it with a slab before the redstone had updated, so I was able to place the slab on nothing. Yeah, it's cool that you can do that. But anyways, now that we're doing this, there's basically just 2 more steps to everything that we're going to be doing today. The first is to just hook these up to the right wires in here, which I'm going to do off camera. The next is to do the ones at the other side, which I'm going to do off camera. The next is to hook these wires, which are the modes, up to the actual mode things over here, and a few other things later, and I'm going to do that off camera. I don't know if you're noticing a pattern here. But anyways, there's one last thing that I want to do today, and that is to, well, I forgot what I was going to do, apparently. But yeah, that's everything that I'm really going to be doing today, and everything's off camera, so yeah. With that, I hope you guys have enjoyed, and I will see you guys next time.
Moses came back with the law. Jesus went into the desert. God only knows what he saw. Hitch up your ass and your camel. Fill up your skin at the well. Roll up your tent. Whisper your prayers. Are you ready to ride to hell? Caravan. Moving through the night. Sleeping in the light of day. Spinning through the void on our way to anywhere. Caravan. Time is just a joke. Change is all we understand. Caravan. Life is a mirage, only a mirage. Dancing on the desert sand. How I recall all the mountains. How I remember the fun. Oh, how I miss the big city with a pretty girl on my arm. Sell my best friend for some water. Cut off my leg for some shade. Sunburn these thoughts from my memory. If I leave, I will be remade. Caravan. Moving through the night, sleeping in the light of day. Caravan. Spinning through the void on our way to anywhere. Caravan. Time is just a joke. Change is all we understand. Caravan. Life is a mirage, only is that bloody oasis? Must be around here somewhere. Time for some slow meditation.